when you look at number 4, the first statement, it's saying in 2004, September, there was a Gallup poll where 73% of 18 to 29-year-olds said that they are registered to vote. Okay, so in number 5, we have a stats professor knows this and wants to estimate the percentage of her students that are registered to vote within 4% with 95% confidence. Basically, how many students should she sample? So what this is doing, let me write I'm going to write in number 4, but I'm answering number 5. Yesterday, I showed you this formula for the first time. Okay? And this is the formula for a confidence interval. All right, so a confidence interval is always a statistic. That's all this is. Plus or minus the margin of error. Okay? So I need your brain to know that the p-hat is a statistic, and the z-star times the standard error of p-hat is the margin of error. So in the problem, when it says that the professor wants to estimate this percentage within plus or minus 4%, that is the margin of error. Okay? So that is the margin of error. So all I'm going to focus on in this problem is the formula for the margin of error, which if you look up here is z-star times the standard error of p-hat. So z-star times, it's not a very good star, z-star. Okay, does anybody remember the formula for the standard error of p-hat? We need something first, the square root. Very good, but because we have standard error, right, it's not p and q, it's p-hat and q-hat. Because basically, Charlize, we say, hey, we don't know, right, if this is from the population. We just have from a sample, right? This is from a poll. Okay? All right, so let's plug in what we know. We know the margin of error that this professor is going for. The professor is going for something that's 4% or lower. So I'm going to replace margin of error with 4%. But you want to write that as a decimal. So write 0.04. Okay, now this is your first day of me asking this question, and I hope that before next week, next Thursday, when we have a quiz, you'll have this memorized. It says 95% confidence. So she wants to be 95% confident. Very good, Bianca. So I'm going to replace z-star. You were so excited for that. 1.96. Okay, so remember, you want to memorize that one. And the other one is for 90%. Do you remember that one, Bianca? 1.645. All right, I'm telling you right now, both of those will be on the quiz. Yes. Okay, can we finish this and I'll show you where that's from? Sure. Okay, so times the square root, and I'm going to use the statistic from the September 2004 Gallup poll. That's why I boxed it, someone boxed it up there in number 4. So this 0.73 is my p-hat. All right, that's the rate that I think these students are being registered to vote. So 0.73 times, so then what's going to be my q-hat? Do you remember how to get that? It's the other way. You can do it that way, just make sure it's positive. So it'd be 1 minus 0.73. 0.27, very good. And you'll notice I'm going to put it over n, because we're trying to find the sample size. We'll start with that. It says how many students should she sample? So we're trying to find the sample size. Okay, so I would say the way that I view this problem, which is going to be the most missed problem on the quiz on Thursday, even though we're doing it right now, for some reason this is, I know why, it's challenging. But this is kind of the first thing you're trying to do, just to set it up. Okay? So you've got to know the margin of error equals your critical value, z-star, times the standard error of p-hat. Because I'm not going to give you that. I'm going to give you this formula, right, the confidence interval, but you've got to know how to use it. All right, and that's what gets tricky about this, okay? Now we're going to do some algebra. So you need a yellow calculator. Okay, so the first thing we're going to do to solve for n, remember we're trying to isolate n, is we're going to move this 1.96 to the other side. So we're going to divide both sides by 1.96. So in your calculator, do 0.04 divided by 1.96. And you should get 0.0204086163. Yes?
Yes.
Now, I'm writing this down because I want to try to be as thorough as possible for you guys and also for anyone that's going to watch it later, which could be you. But just know, I would never write that down. Actually, I wouldn't even write this down because, I mean, I know how to do the algebra. Right? Because if you are a student in my class and you write this and then you tell me n equals the answer, that's cool by me. Right? Because all of that after this is just algebra. Now, it's a little tricky. I will say it is tricky algebra. Okay, so now what I do is I have to get rid of that square root. How do you get rid of the square root? You square it. So I'm going to use a different color. Thank you. Whew. So I'm going to square both sides. Okay, and when you square both sides, so if you square that number, go back to my original color black, and I'm going to write 0.000416493 equals 0.73 times 0.27 over n. Now this is where it gets a little funky, all right? Because we're trying to solve for n, but right now, where is n? It's in the denominator. So you can think of this as a couple of ways, right? Some teachers would teach you to put this over 1, and then you've got a proportion, so you could do cross products, right? Cross multiply, and then set them equal to each other, right? The way I do it, I think, Bianca, is what you're going to do. I just multiply both sides by n. Okay, so if I multiply both sides by n, then my n moves to the left side. So I have 0.000416493 times n equals 0.73 times 0.27. So the very last step to get n by itself is to divide both sides by 0.000416493. Now again, I showed you all the steps here in algebra, but you don't have to for the quiz. Like, I'm not grading work on this. Okay. Whew. So if you use your calculator and do 0.73 times 0.27 divided by that 0.000416493 number, you get n equals 473.24 or 237, yes. Okay? Now, what are the units going to be for this question? It's going to be students, right? So when I write this, can I have 0.24 of a student? No. So this is an example where if this professor wants to have margin of error within 4% in either direction, then she is going to need to always round up. Okay? So I get every year students like, oh, the answer is 473. If that professor uses 473, then that professor may not get 4% margin of error. They might get 4.1% margin of error. Okay? So that's why I always tell students, always round up. Okay, so the answer is actually, she should sample 474